Hello, in this problem, they give us an h of x and they want us to find the derivative of h of x by using the fundamental theorem of calculus, which I have listed up here. The problem, though, is that in the fundamental theorem of calculus on the upper limit of integration, we have just a plain x, but we don't have just a plain x up here. We have a sine of x. So what we got to do is use substitution, and then use the chain rule to figure out what our derivative of h is. Okay, so the first thing we got to do is we got to assign u to that upper limit of integration. And right off of that, can we do du dx? I think the derivative of sine x is just positive cosine x. Okay, so we have this part of the chain rule. Now we got to figure out the dh du. How do we do that? So we have to do dh du is equal to, let's see, we're going to sub the u in where we had that sine of x, right? But we still have the same thing. We have cosine of t cubed plus t dt. So now if you look, I think we can see that this fits in with this fundamental theorem of calculus where instead of an x we have a u. So we can just rewrite this cosine of u cubed plus u. Okay, so now we can just go back to our chain rule. So our dh dx, which is what we're looking for, is equal to dh du, which is cosine of u cubed plus u times our du dx is cosine x. Okay, so then the last step that we have to do is just do our substitution. Right, so it's equal to the cosine. So instead of a u, we have a sine of x cubed, right? Plus u, so plus sine x. Right, so this whole thing is in parentheses, and then we still have a times cosine x. So it's kind of long, it looks kind of confusing, but that's what the final answer would be. So be careful when you're typing these in with the parentheses. Okay, that's where I tend to mess up, is I leave off parentheses or I put too many in. You know how it is. So hope that helps.